Dr. Pot is my hint. Or RG Cobb. What do we learn to do? Run all answer at once. Out of control, yeah. And? Yeah. So, we learned Dr. Pot, where we did degrees to radians. On top. So we multiplied by pi of 1/8. Then we did RD Bob. Radians. 2 degrees. Pi on bottom. Is 1/80 over pi. What else do you learn about? Any other things you remember? Starts with a C, rhymes with coterminal. Oh, coterminal, yes, good job. So we learned about coterminal. Coterminals, where if it was in degrees, you add or subtract what? Yeah. And if it's in radians, you add or subtract pi over 2. Pi over 2. Try again. 2 pi. General solution we learned. The general solution you went theta equals, and then this was your principal angle. What is a principal angle? Remember? For the general solution, we will start off with the principal angle. The angle between what and what? 0 and 360, or in radians would be 0 to 2 pi. So remember, if we have an angle, they ask for the coterminal and general solution, we have to find the principal angle first if they didn't give it to us. And then we add 360 degrees and NEI, or principal angle, sorry, in degrees, or we have the principal angle and we add 2 pi and NEI. Right? So that was that. We also learned about something that starts with an R. Rhymes with reference. Ah, reference angle. Everyone's just got it all past that. Down on fire. So I think didn't want that recording for that. Okay. Reference angle. Reference angle, what is that? The angle between the terminal arm and the... Yes, I didn't have to make it round with steps. Good job. Okay, so reference angle is the angle between the terminal arm and x-axis. So it's your bow tie angles, right? They're always less than 90, right? They have to be, because these are where my terminal arms are. My reference angle is this, and this, and this, and this, which has to be less than 90, right? It would max out at 90 if I had like 270 or if I had 90, so I have to go all the way to there. That's it. Yeah. Yep. Yep. Ah! Yes. Thank you. Megan thinks they're going to freak out because they're going to think that the small packet didn't have any volume, but that one has volume because genius, you should win an award today. an award for best observance. You know, I remember I have to make you guys all awards by the end of the year. I have a whole year to think about what I'm going to give you. At the end, I'm going to give it to you in, I'm going to actually like buy awards and give you awards. They might be plastic trophies or they might be medals. I don't know. I'm going to, right now, Observatory Award goes to, currently, but I may switch it up. I have till June. All right. We have a mic now. And hopefully they have a mic now. But really, do they need to hear all that other stuff? No. I can pause it so they can hear something that mic wasn't plugged in. That's kind of comical now, thinking about it. All right, so we reference angles. What else do we do? I gave you a coordinate and asked you to do what? Give me the 6 rhymes with fig ratios. 6 trig ratios, yes, exactly. So I give you a coordinate. Example might be 3, 4, right? And then I made you give me the 6 trig ratios. How did we do that? We drew the point, the terminal arm through it. So you gave a coordinate on the terminal arm. Is the key thing. We had a coordinate on the terminal arm, and then we would sketch it, and then we would find the radius, which was always positive, and then we would get the trig ratio. Yes? Like cook extra rice, or tan your Xbox, or sign your resume, ransom, rabbit, options, right? Just to make sure we sign something enough. Then yesterday we did what? Yes. Yeah, we did solving. We had to find trig ratios, and we had to find angles, correct? When I gave you a trig ratio and another piece of information. So, when you're given a trig ratio plus information to know what quadrant this is, right? So an example would be tan theta equals -3/2, and sine theta is less than 0. Right? And then I can ask you for any of the other 5 trig ratios, right? Cotan, be stupid because you have tan, if you just flip it, you have to know where, or secant, cosecant, sine, cosecant, yeah, cos and secant. So I can ask you for the 5 other trig ratios. In this case, I asked you for cos. So we go through the same steps. We go tan negative. Tan is negative here and here. So I have 2 options. And then hopefully they give me a piece of information that narrows it down to one of the others, right? If they don't, I have to use both arms. And I'm answering 12 trig ratios. Or tan, yeah. Yes. The reason why you want to draw it is so that you know if your other side is positive or negative. So in this case, because it's x and y and it's tan, no big deal. The radius has to be positive. But if it's sine or it's cos or cosecant or secant, then we have to know what quadrant it lands in. We don't know if the x or y is positive or negative, right? Yeah. So this one's sine has to be negative, so this one's out, because that's what sine is positive, so I know it's here. Now, like I said, this is y over x. So this one is not a big deal because your radius has to be positive, but if they give you the radius, you have to draw it to find out if your x or y are positive or negative. So then we would go r squared equals -3 squared plus 2 squared. R squared equals 9 plus 4. R squared equals 13. And then I get plus or minus 13. And in this case, r has to be positive 13, root 13. So if I had not drawn it, I would have been okay. But for secant, cosecant, sine, and cosine, I have to. And then I want cos. So cos theta equals cook extra rice. So it's going to be 2 over root 13, and then rationalize. Another thing we did was a lovely huge thing that you take out every single day of your life till the end of time, well, till the end of the class. It's this big thing, it's kind of circular. The unit circle, we talked about the unit circle. We talked about coordinates on the unit circle. We talked about being on the unit circle. When we read on the unit circle, what did we always have to think? When we read on the unit circle, yeah. Exact values, yeah. R equals 1, what else? Yeah. Yes, all of those are true. So we have x squared plus y squared equals 1. If it says a coordinates on the unit circle. We also know that if it's on the unit circle, our radius is 1. We also know that if it's on the unit circle or it says exact values, we must turn to the unit circle. They're all information, right? So when I said exact values, that was a huge hint that you're probably pulling your answers off of the unit circle, right? It says on the unit circle, we know the radius is 1, so we know we're going to use x squared plus y squared equals 1, because that's the formula of a circle centered at 0, 0 with a radius of 1. So what I did is I would give you, for example, I could say 2 comma y is on the unit circle. And then I would make you solve for y, correct? Indirectly making you fill it into what? X squared plus y squared equals 1. Okay? Now you would get 2 solutions, wouldn't you? You get a positive and a negative. So unless I give you a quadrant, your y will be plus or minus. You get 2 quadrants. So how do we do that? We go 2 squared plus y squared equals 1. 4 plus y squared equals 1. Tell me you see a problem. Y squared equals negative 3. What's our problem? Yeah. Squared is negative. So what's our catch have to be here? Can't be 2 because that's a unit circle. This value for x and y has to be less than what? Yeah. Because when you square everything less than 1, it stays less than 1, right? Now you have to subtract from 1, aren't I? So could I have instead went 0.8 in y? If you have how many in the circle somewhere possibly? Okay. Now, when I gave you points and asked for the trig ratios, they weren't on the unit circle, were they? So this coordinate up here, when I gave you this coordinate, it was 3/4. That was totally fine because it said given a coordinate on the terminal arm, it doesn't say given a coordinate on the terminal arm of the unit circle. It just says the coordinate on the terminal arm determine the other 6 trig ratios. Totally different, right? So then these two numbers can 100% be bigger than 1, right? Because these coordinates were never on the unit circle. But if I see them on the unit circle, it's going to have to fit on, right? So we can't be outside of that one. All right. The other thing we did was exact values. Trig ratio. When I said exact values of trig ratios to determine the exact value of the trig ratio, you have to a unit circle and pull the information out the outside, right? If it was cos, it's just what x is. If it was sine, it's just what y is. If it's cosecant, it's sine flipped. If it's secant, it's x flipped. to our formula sheet, our tan formula sheet is sine divided by cos. You have to do y divided by x. Cotan of our formula sheet is cos divided by sine, so you get 2x divided by y. Okay? So I gave you an example on the board. I don't know why I wrote example, but whatever. Cosecant squared 5 pi over 4 plus cotan of 7 pi over 6. Now you can do these right embedded in the question, or you could figure out cosecant 5 pi over 4 off to the side if you really wanted to. Okay? So it's more math. I would just do that to the side. So for myself, I would go cosecant of 5 pi over 4. So I'm going to go to 5 pi over 4, which is on the unit circle. What if it's like too big? It's outside the 0 to 3, 6, 0 to 0 to 2 pi. What do we have to find? Yeah. Coterminal angle. So if it's too big or it's too little, we can find the coterminal of it. So it terminates on the same line, still gets the same answer, right? So there's that step that might have to happen in the middle and then do coterminal. So what's cosecant of 5 pi over 4? What's sine of 5 pi over 4? Yeah, negative root 2 over 2. The cosecant is just that clip, right? So it would be negative 2 over root 2. And then we have to rationalize, and so I'm doing it up to the side. So I'm going to get negative 2 root 2 over 2. And what happens? 2 cancel, and I go negative root 2. So as long as I show it off to the side in a nice, neat manner, me marking this would be like, yeah, I totally understand that. Here's the algebraic process. Good. And then I can go back here and I can go negative root 2 squared. Because remember the squared in here? All it means is cosecant of 5 pi over 4 squared. That's what that means, that squared in there. So they write the squared in the middle. They write the squared in the middle. But if you want to type it into your calculator or you want to actually do the algebra, it means that squared. Okay? Then we go plus cotan of 7 pi over 6. So I'm going to do that over here. Cotan of 7 pi over 6 equals cos of 7 pi over 6 divided by sine of 7 pi over 6, which equals, what's cos of 7 pi over 6? What do we get? After your circle, what do you get? Yeah. Negative root 3 over 2. And then it would be stacked, but I don't write it stacked. And then what's sine? Negative. We get negative root 3 over 2 times 2 over negative 1. And then I get negative root 3 over negative 1, which is root 3. I have to have an equal sign because this equals this. Equals. If I square the negative, it becomes positive. If I square the square root, it goes away. So I'm going to get 2 plus root 3. And that's as pretty as it gets because I wanted exact values, right? I don't want you to go to one step and type in your calculator and make decimal because you're actually smart. You'd be okay. Yeah. So if you didn't want to rationalize the kind of square, going totally work. Yeah. Now, I can type this in my calculator to see if this matches. So go 2 plus root 3. I'm going to show you how to type that awful other one because we don't have those buttons, right? So we have 2 plus root 3. People will say, demonstrate radians or degrees. Are you pressing the sine, cos, or tan button? Nope. So it doesn't matter what mode you're in this very step. So 2 plus root 3, what do you get approximately? 3.73? 3.73? So it's approximately what we're at. Do we want to write that in this answer? No, we want exact values. But we want to walk away being like, yes, I got this right. Ooh, this is bad. Go back, try again. So how the heck do I type in that awful cosecant stuff? So I know I have cosecant 5 pi over 4 squared. At minimum, I know I have to do that plus cotan of 7 pi over 6. At minimum, I know I need to be in radian mode, correct? Right? Now, please, if you're stuck on how to type these in, help me. There's this thing called a formula sheet in front of your face, and it tells you exactly how to type it in. So grab your formula sheet, and we're going to look for cosecant at the very top. Right. Very top right. Cosecant equals what? Cosecant equals what that I can actually type in? 1 over sine, right? So it says that I can replace this with 1 over sine, correct? So I'm going to rewrite it as 1 divided by sine 5 pi over 4. My formula sheet tells me how I have to type it in. And then that whole thing's going to have to be squared, correct? Plus, and how do I type in cotan? Please will say cos over sine. You actually can do that. But it's an easier button. 1 over 10. You have a 10 button. But if you type in cos of 7 pi over 6 divided by sine, would that be a problem? That just be more buttons, so it would be totally fine. But this I can replace with 1 over 10. Alex, let's 3.73 look at it. Okay. So you guys are going to type it in until you get that answer. Try it out. Okay, the only other thing we did was the theta equals A over R. And you have to remember this is arc length. This is radius. These have to be in the same what? Same units. So if 1 centimeters doesn't have to be in centimeters, most often I'm noticing them not, but just note they do have to be in the same. And this theta, this is the big thing. This theta has to be in what? Or we have to be in radians. I feel like I wish this could happen, but it doesn't. I feel like if you put a degree in, it should like just probably like when you go to your formula on your sheet and put a degree in there, it should just like jump back out and be like, get back in there, and you jump back out and you'd be like, why is it jumping out? And you'd be like, oh, it needs to be in radians. Or you just be like, I can't take this formula, it's jumping out on me. Wouldn't it be great if like when you're filling the formulas and you did something illegal that would like jump out, and you'd be like, wait a second. What am I doing wrong? We need that. We need that. Jump out. Amazing. Okay. So your notes right here, approximately 14 pages in, 17 or something, I don't know. Go find that. The first thing you always want to do in this instance is it'll say sine when we let 2 over. So we're going to sine theta equals a half. Okay. This is where I need you to pay attention to what it's asking. So, on the bottom of the here to the right was that question I asked you to do, which was tan theta equals negative 3 over 2, correct? This is sine theta equals a half. They look very similar in question format, right? One is trig ratio equals fraction, one is trig ratio equals fraction. Very similar. So you need to be able to spot the difference of what the heck it's asking. The previous one we did on the other day, which was yesterday, I gave you a trig ratio. I gave you another piece of information so you could figure out which arm to draw it in, right? And then I asked for trig ratios, didn't I? So I gave you a trig ratio, gave you a quadrant somehow, asked for a trig ratio. We agree? Today's lesson, I'm not asking you for trig ratios, am I? I'm saying find theta. Or I will say solve. All I have to actually say is solve. Because solve means in every math unit, in every math lesson in the world, solve means there's a variable. I need you to tell me what the heck it equals, right? That's all solve means. It doesn't matter what unit we're in. If I say solve, I need variable equals answer boxed at the very end, right? You can do some algebra. The algebra in the middle might be totally different because it might be trig, or it might be a polynomial, or it might be a rational, or it might be a radical, or it might be an absolute. So the actual math you do might not be the same. But ultimately, in the end, you're going to have variable equals answer and boxed, right? That's what solve means. So if when on a test I say solve and you have variable equals answer boxed, you didn't do what I asked, right? The math in the middle might be totally different, but I need that as an answer, okay? So this one says solve or find theta. So I need to actually figure out what the heck theta would be. Okay? All right. If your answer is a half, root 3 over 2, root 2 over 2, 1 or 0, any of those answers, or root 3, or negative 1 over root 3, or root 3 over 3, those are 10 answers, right? If it's any of those answers, you're going to be able to go to your unit circle and just find the answers off of it. So for this one, I want to know where sine equals a half. So we go to our unit circle, and I want to know where sine equals a half between 0 and 360. What is on your unit circle? What is sine on your unit circle? Y, because it's Calgary Stampede. So I'm going to go look at my unit circle, and I'm going to look for when y is a half, positive. Remember, this is sine positive, so it's going to be in quadrant 1 and 2, because sine is only positive in 1 and 2, so that's where I'm going to look for it. So where is it at? Where is sine equal to positive a half? Where are my y's equal to a half? Yeah. Boom. And my answer, right? Now, because it says between 0 and 360, I'm good. If it says between 0 and 2 pi, I would not be good. If it said between 0 and 2 pi, my answers would have to be pi over 6 and 5 pi over 6. You have to look for your domain. If your domain is in degrees, your answer is in degrees. If the restricted domain they give you is in radians, your answer has to be in radians, so they won't be marked. Okay? What happens if I changed it to this? What if instead of 0 to 360, I actually said 360 to 720? What would I have to do? Yeah. Find the coterminals that fit, right? So I can always get my principal angles right away. But then I look to my domain and I say, do these fit in the domain? They fit in the domain of the original. Oh, I gave a different domain. I'm going to have to add 360 to them. So if I go theta equals 30 plus 360, I get 390. Does that fit? Yep. Theta equals 150 plus 360, and I get 510. Does that fit? Yeah. So my answers are going to be 390, 510. So we still always find our answers off the unit circle, off our principal angles, but we might have to actually doctor them with coterminals so they fit in the domain that they gave us. Okay? Does that make sense? If they said from 0 to 720, then my answers would be 30, 150, 390, 510. It would be all four. So they can give us whatever they want. They can give us negatives. They can go from negative 180 to 180. So what if they did that? What if they restricted the domain instead to negative 180 degrees and 180 degrees? My principal angles were 30 and 150. Do those fit in there? Negative 180 to 180. Negative 180 to 180 means negative 180 to 0, 0 to 180. So both of those actually fit in the 0 to 180 column, correct? Now I want to check their coterminals. So I'm going to subtract 360. I subtract 360, I get negative 330. And if I subtract 360, I get negative 210. Do those fit? Actually, that looks like 338. Do those two fit in the domain of negative 180 to 180? No, because they're bigger than 180, right? Negative 180. So these two actually wouldn't fit. So I'd actually get the same answer as the beginning if they had restricted it from negative 180 to 180, because sine is positive in the first two quadrants. Okay? So on a separate sheet of paper, I'm going to get you to do another one that's nicely off the unit circle. So I want you to do not sine, sorry, cosine theta equals negative root 3 over 2, and I want it between 0 and 2 pi. Find where cos is negative, or where x is negative, which is here and here. Which thetas does that fall into? Right? So nice and easy when it falls between 0 and 2 pi, correct? We agree? What if I say negative 2 pi is less than or equal to theta is less than or equal to 0? But it's like this is the next easiest one they could give you. Why? It's a full negative rotation, isn't it? From 0 to negative 2 pi is a full negative rotation. So I could just take these two answers and find their coterminals, right? By subtracting 2 pi, and it'll fall in that next negative rotation. So if I restrict it to this domain, I would go theta equals 5 pi over 6 minus 2 pi. So it would actually be 5 pi over 6 minus 12 pi over 6, which equals negative 7 pi over 6. And then theta equals 7 pi over 6 minus 12 pi over 6. That would be 2 pi, which is negative 5 pi over 6. Could I have converted the negative 2 pi and 0 to degrees and said it's negative 360 to 0, find it all in degrees, find it to fit, make it all fit in degrees, and convert to radians at the end and give my answer radians? As long as I have algebra along the way, and radians is my answer. So you could convert that to degrees along the way, make sure it fits, and convert it at the end. Right? All right. What happens when they're not off the unit circle? So this one. Cos theta equals negative 0.8090. That doesn't scream unit circle to me. Okay? When this happens, you have steps you have to follow. Okay? Paying attention, this is where it's harder. So step one, when you get something, is you have to first get it into cos equals whatever, sine equals whatever, secant equals whatever. You get by some. But then step one is to get the reference angle. In order to get the reference angle, you're going to do the opposite. So inverse trig of the positive always. Remember I told you the positive? And the reason why we do positive is we need to know why we do it so we don't forget to do the positive. The reason why we do the positive is if we take the inverse trig of a positive, we'll always get quadrant 1 angle. And quadrant 1 angle is equal to your reference angle. They're the same, right? So when we want to do the reference angle, we're going to go theta equals cos neg 1. And I do not care that this is negative. I'm going to do the positive to get my reference angle. Because if I'm ever finding a reference angle, I always do the positive. Okay? Always, always, always. So even if it's negative, I don't care. I'm going to do the positive. So we're going to do this in degree mode for now. We're not going to do the radians. We're just going to do degrees just for now because degrees might be easier for us. So make sure you're in degree mode. Second cos 0.8090. And what do you get as a degree? Can anyone do it? Right? 36.0. Do we agree? We shall. So we want to go to at least near 10 or 100, right? Is there more decimals to it? 0.16, I'm going to do that. The reason why I'm going to keep more is because this question is actually in radians, right? So when I convert in the end, I don't want to lose some decimals in conversion because I shorted my degrees. Okay? So that's my reference angle. That's step 1. Step 2, cast rule, to find out where the heck the reference angle falls. Because I could actually have the reference angle in 4 spots, couldn't I? I could have it in quadrant 1, quadrant 2, quadrant 3, quadrant 4. I need to figure out which quadrants I have to have it in. So step 2 is cast rule. So, in this case, it's cos theta equals negative 0.8090. So I'm looking where cos is negative, right? Where's cos negative? In S and T, right? Cos is also negative when X is negative. So it's here, right here. Number 3, use reference angle, good answer. So if I know my reference angle is 36.0, it's here and it's here, right? It's the big triangle, isn't it? So to get this angle here, what am I going to do? I'm going to do 180 degrees minus 36.016. And for this one here, in quadrant 3, I'm going to do 180 plus 36.016. So what does this one get me? The first one. And to be honest, I would have just held that decimal if I had a calculator where I can go up and I would take the whole thing. So I'm going to get 143.984 degrees, which is a lovely degree. And 216, which is also a lovely degree. But my domain is in radians. So what am I going to have to do at the end? Convert. So degrees to radians, Dr. Pop, degrees to radians, pi on top, right? So I'm going to multiply by pi over 180. Do you see how my first few lessons culminated to me being able to do this question? I have to be able to convert. I have to be able to find a reference angle. I have to be able to know how to use a reference angle to get the actual angle. All of this comes together here. This one I get 3.77. And this one I'm going to get 2.51. And we know we're right because 0 to 2 pi is 0 to 360, correct? And we know that 143 and 216 fall between 0 and 360. So their radian measures are going to fall between 0 and 2 pi, correct? So my theta equals 2.51, 3.77. Okay? So we're going to go way back to transformations. When we did transformations, I said to you, in order to do the transformation, you have to make sure it's in y equals, and you have to make sure there's a 1 in front of the x, correct? That was my rule. We have to memorize it, and we can do all of our transformations and not mess them up. Okay? For solving trig, my rule is, so I'm not even putting these steps, because I have 3 steps. Reference angle, cast rule, use reference angle, get angles. Correct? That's my 3 steps. I'm not going to add more steps to that, but I'm going to tell you that in order to use those 3 steps, your equation has to be in the form sine, cos, or tan equals number. Sine, cos, or tan equals number. Okay? So the previous one was in cos equals number, correct? This one, I'm going to get cotan theta equals a quarter. We agree? Is that in sine, cos, or tan equals a number, though? Is that in the right form? No. We do know this, though. We know that if I give you sine, you can give me cosecant, correct? If I give you sine theta equals something, you can give me cosecant because you're just going to take sine and flip it. We agree? If I give you cos theta equals 2 over 3, you tell me secant theta equals 3 over 2. You just flip it, right? So if I give you sine, cos, or tan, you can flip it and get your secondary trig ratios. We agree? So if I give you a secondary trig ratio, what could you do to get the primary one back? If I give you cotan equals a quarter, can I get tan back? What can I do? Just flip it. That's it. That's all it is. So the reciprocal of tan is cotan, but the reciprocal of cotan is just back to tan. That's all they are. So you're only flipping answers. You're never flipping angles. Okay? So is 1/4 an answer? Yep. So I can flip it and get my tan back. Right? So I can go tan theta equals 4. And now I'm back to being able to use my 3 steps. Reference angle, cast rule, get my answers. Reference angle, cast rule, get my answers. So in transformations, I told you it has to be y equals, and I have to have a 1 in front of my answer, I'm going to mess up. In trig solving, what I'm going to tell you is, you need to have it in sine, cos, or tan equals number. And then I can do my 3 steps. Okay? So, now I can do my 3 steps, because I can do my first one, which is reference angle. Reference angle. I'm just going to go theta equals tan meg 1 of the positive. In this case, we left out because it is the positive, right? I don't have to make it positive, it is positive. And we can type that in degrees. To be honest, I would solve all of these in degrees of first meridians because you're going to get super confused. You can keep it in meridians, totally. Go for it. You're just not going to know if they fit half the time. You'll be okay if you actually do the meridians. I'll show you why. On a radian one, but we're going to keep it in degrees because this is actually in degrees. So a second tan of 4. So I get 75.964. Okay? I do 3 decimal places, but it is. Then step 2 is cast rule. For cast. Thinking about those cattails that save people from going into the swamp. Okay? Cast. So we have tan of a positive answer, correct? Tan theta equals positive 4. So I need to go where tan is positive. So use my cast rule. Where is tan positive? In the all and the tan, right? And I just found this and this is 75.964 because those are my bow tie angles, right? So boom, I have this one already. That one was easy. This one is theta equals 75.964 degrees. How do I get this one? You don't have to. Why? Restricted domain. Because that's going to be outside of it. It's going to be too much. I'm going to show it anyways. So we're going to go 180, but you wouldn't have to at all because it's outside. You are completely correct. So if I go 180 plus, I'm going to get 255.964, which is a lovely answer. It really is. but it's outside my domain. So in the end, I'm going to say theta can only equal 75.964 degrees opposite. Okay? I'll give you some questions that you're going to work on. There are more. There's more to solving than this, but I just want you to practice the basic. I either give you a sine, a cos, or a tan, or I give you a secant, a cosecant, or a cotan, and you have to solve. I just want to try the basic ones first. I don't want to add more onto it, or it's just too much at once, and then nothing sticks. Too much stuff on a dartboard and hoping something sticks. I don't want that. So, remember, if it looks like root 3 over 2, or root 2 over 2, or a half, right, or 1, or 0, we think, I don't even have to do these 3 steps. I can just go right to my unit circle. Could you do the 3 steps, though, every single time and get it right? Yep. You could absolutely, every single time, do reference angle, casserole, answer, and never touch your unit circle. So if you don't recognize root 3 over 2 is off your unit circle, no big deal. You could do the 3 steps and still get it right. Okay? So, page 211. Number 1, it says without solving, I don't care if you use solving. So without solving means go to your unit circle and pull them off. But if you use the reference angle, casserole, answer for number 1, 2, that's absolutely fine. Okay? So ignore the instructions without solving. That's number 1. And then I want you to do number 2, A and D. And number 3, I want you to do C, D, E, F. Okay? I need you to practice those, and I need you to do them tonight. And the reason why is normally I say do your homework and make sure it's done for Friday. I need you to make sure you can do this for tomorrow, because we're going to advance on, right? So if you don't practice this and you don't do good at this, tomorrow is going to be a little scary. Yeah. And by 2, what? So this is a 3 and this is a 4. Why is it? I don't want you to do 2 at all. I don't even know why I have 2 up there. That's just dumb. This is a 3 and this is a 4. Don't do 2. It's dumb. I'm dumb too because I wrote the wrong number.